Okay. Good evening and welcome everyone. If you could please take your seats, we'll get started here very shortly. Okay. Well, welcome everyone. Alex Thompson is my name. I am Albemarle's Vice President for Lithium Resources. It's great to be here again, and we're very much looking forward to providing an update on the Kings Mountain mining project. Since we last caught up in March, there's been a lot that's been happening, and we're going to provide a bit of an overview today as to some of those work streams, and you'll get the opportunity to hear from some of the team members that have been busy working in the field. There are a number of highlights that I want to sort of touch on, and I think one of the key things that you've probably all seen as you've been in and around the community is just the level of activity that's been taking place on site. We have increased the number of people in our team. We've onboarded at least 40 to 50 people that are both temporary and full-time employees that now call Kings Mountain and the Gastonia corridor home. We have advanced a number of the studies that we need to advance to be able to submit our permits in due course, and we've also started and in some instances completed a number of those key milestones along the way. In addition to that, we've also had a number of community sessions held at Big Red's Cafe. Some of you have attended those and we've had the opportunity to interact, and it's great to sort of be able to come together again today to talk more formally and give you an update as to what's been happening. All of us here at Albemarle are very, very excited about the potential that the Kings Mountain mining project has. The pathway to getting there is dependent on bringing you along that journey, but we're focused on developing a safe, sustainable and successful operation that we can all look at and be very proud to be associated with. While we still have a lot of work to do, we hope that you leave today's session with a greater appreciation of where we're at, and any questions that you have been answered. I'm now going to hand you over to Fernando Rodriguez, who is the new Site Development Director. Fernando joins us from a career that has spanned the globe. He's been here in the US for the last 30 plus years, and he's been involved in the operation and restart of a number of world-class operations, both here in the US, in Arizona and Utah, and also around the world in Chile, Peru, and Armenia. Really hope that you enjoyed today's session, and I'm now going to hand over to Fernando, who will take you through the rest of the session. Thank you.
Good evening, everyone. Thank you for coming today. So thanks, Alex, for the introduction. I'm very excited to be part of the team and part of the community. Like Alex was mentioning, I've been going around the world working in different projects. So I'm very proud to be part of this development of this mine. So like Alex mentioned, I'm a mining engineer. I went to school in New Mexico, School of Mines. So it's been great, this career that I have done around the world. And I hope that, I think this will be my last rodeo, like I told some people. I want to stay here and work with the community and develop this project. We are working right now on the phase, the studies of the project. We're looking at different scenarios, different things that we will be putting together a package for our permit. So we have retained, we have hired world-class team. We have a lot of people that have joined the team lately. They are mostly high-skill, world-class, that has a lot of knowledge and specialties like geology, chemistry, geochemistry, geotechnical engineering, and all it has to be related with the study. So, like I said before, I'm very excited to be part of the project. Today, we will be able to show you what we are doing. The team has prepared some slides showing exactly where we're at. And like we mentioned before, and we are studying first, evaluate the project, evaluate the site. This is a site that everybody knows used to be in operations until back in the 1980s. So we will look into everything that we have now to be able to create a process and develop the mine according to the highest standards that we have in the world and the US. So very important for us. We need to understand that lithium is going to be part of a great opportunity to clean up the air, using the batteries that will power the future. So this is going to be the first lithium hard rock mining that we produce lithium hydroxide to power the batteries for the electrical vehicles. So we're going to be looked from different places what we're doing here. So my commitment is to work with you, work with the team, deliver a project that is sustainable. It's going to help us, the communities, and help us everybody to develop this mine. We want to work with transparency, and of course we want to do what is right. So that's my commitment to deliver this project. With that said, today we are going to be updating on the different studies. We're going to talk a little bit about the geology, look about the permitting and the environmental studies that we're doing. And also, we're going to be looking at some of the work the community relations teammates are doing. So with that said, I would like to turn it over to first, as in every meeting that we have in King Mountain, we talk about safety. So I'm going to introduce Ron Lindsay. He's our safety manager. You're going to talk a little bit about our core values first, and then have a little bit of a safety share. So Ron, please.
Thanks, Fernando. Good evening, everybody. As Fernando said, my name's Ron Lindsay. I'm the Health and Safety Manager for the Lithium Resource Project at Kings Mountain. Today is actually my 66th day at Kings Mountain, and I'm proud of that. Also, with that being said, I do have 29 years of mining experience, and 15 of them years have been in the safety field. I don't know if any of you all have ever been to the Kings Mountain site, but when you first pull up to the security gate, there's a big sign out front, and it says how many days we've gone since our last recordable injury. And this morning when I went through that gate, it said 1,055 days. That's a long time. 1,055 days. That's a big deal. That's 2.89 years, or I don't want to jinx ourselves, but that's 40 days less than 3 years. And so, and we didn't get there by chance. We didn't get there by luck. Albemarle provides us with a numerous types of safety programs, policies and procedures, and different things that I call safety tools, so that every employee and contractor that comes to our site can go home safe to their families every day. And one of the safety tools that I think is one of the most important is what we call a safety share. Okay, and what a safety share is, it's just an impromptu comment or discussion initiated by anyone with his or her peers. It can be about work or off-job stuff. Okay, the safety share takes place before work begins and before meetings, kind of like we're doing now. And the point or the intent of the safety share is to just share information that others could take with them so that they don't get hurt, so they can go back home to their family every day. Okay, I've worked at a lot of places that have safety shares, and it's such a simple thing, but it's such a powerful tool. And Henry and I was talking earlier this week about safety shares, and some of the best ones that we've ever heard are just about a minute long, if that, just real short to the point, and just a good tool to use. Some other things that we use as our core values. I think they're on the screen there now, right? So we have our core values, and what a value is, it's just a fundamental belief that guides our attitudes, our choices, and our actions in all respects. Okay, so a value won't change. So if you value something, that doesn't change, and that's very important in the safety world, because priorities can change. Okay, priorities change, but if you value safety, that never changes. And if you look at them core values right there, the very first one says care. And it says, we value the safety and the well-being of each other. Okay, so if we value safety, so if we hold safety as a value, then safety is the guiding principle behind every single thing we do. And that's one reason we've gone to 1,055 days, and we're just going to keep going, because we value that safety. Again, I told you earlier, I've been here for 66 days, and I'm going to be honest with you, them values right there is one of the main reasons I'm here. When I read them values, they align with my personal values, and that's important to me, so why wouldn't I want to be a part of this team? And as we go through this town hall tonight, I know you'll see that we are living and demonstrating these values. And so I thank you for your time, and I'll turn it back over to Fernando.
Thank you. Thank you, Ron. Very important, safety as a value. We live our values every day. We make sure that we take ourselves, safety on our own, and also we take care of our co-workers. Now we're gonna go through some of the updates on the studies that we're doing. Important here is that at the end we're gonna have some Q&A, some questions for you to ask, and we have here the team to answer. If we can answer, so we will take them with us and get it back to you as soon as possible with the answer that we need to do. So with that, let me introduce Matthew Hastings. He's our geologist. He's going to talk about the deposit of Kings Mountain lithium.
Hi everybody. Hopefully you can hear me all right. I need to kind of gesticulate and point at things. So I want to start by talking about, first of all, who am I? My name is Matthew Hastings, group geologist. One of my responsibilities for Albemarle is to be able to describe the unique geology of Kings Mountain. And that's the word I want you to keep in your head, is unique. The current Kings Mountain area is kind of shown here. The mine area that we're talking about, that Albemarle is working with, is right here. Our neighbors to the north is Mark Marietta, right there. And a little bit about the geology. About 500 to 700 million years ago, Kings Mountain was a marine environment. So sedimentary rocks were kind of dominant here, and that's what we can see here in kind of the greens and the oranges over here. Sometime after that, all of these rocks were pushed deep underground. We don't know exactly when, but somewhere in that range. There were a lot of intense heat and pressure that was kind of subjected to these rocks, and so everything was metamorphosed. Over time, that pressure got to the point where things started breaking. And so when you can see this big line right here running between, for example, our pit here at Kings Mountain and then the pit here over at Mark Marietta, this is a shear zone. So the two rocks that sit on either side of this are completely different, separated by hundreds of millions of years. You can go stand and straddle that contact if you want. These rocks move side to side, so they're different. They're not the same rocks. A lot of people ask that when they come out and visit, is what's going on up here the same thing that's going on over here? Absolutely not. It's completely different. So where are the things that we care about, where do those come from? So about 350 million years ago, all of these rocks were intruded. So that means we have magmatic rocks that pushed up through these sedimentary rocks. You can see these kind of odd-shaped things over here. These came up. Over time, they started to cool, millions of years, and the fluids that came off of these moved over. They flowed along these pathways that were developed by this big shear zone right here, and they concentrated right around in here. You can see them kind of sitting here in the pit area, going all the way to the south. We know that they go elsewhere along this big shear zone. So this is really kind of the last gasp. After these things cooled off, those fluids concentrated light elements. Lithium is a very light element. So lithium is one of the things that was concentrated into these kind of blue swirly shapes there, which we know as pegmatites. So that's the rock that we mine, is the pegmatite. The mineral that is contained within it is known as spodumene. So I want to spend a little bit of time talking about what we've been working on from a geology perspective and where we're going in the future. So these pegmatites have actually been known for a very long time. As early as the late 1800s was when they were first mined for a variety of things: tin, tantalum, all sorts of different elements. Where did we start? We started with where the old timers stopped. This is a map from the mid-80s, when the mine there was in operation, and what they kind of knew about the pit. We take their understanding and their interpretation. So we can see here, this is a cross-section showing the drilling that they had done back then and their interpretation of that ore body. We take that and we start trying to build on it for modern times. We start running geologic mapping exercises. So this is literally geologists out in the field looking at the rocks, trying to understand where things are going, and we reconcile that with history. These maps are, in some cases, date back to 1918. We drill. Each one of these lines here on this map is a drill hole where we recover core samples out of the ground. Right now, this is all taking place on our property in the pit area, and we collect a lot of data and information from that. This is an example of all of the data information that we use to try to understand what's going on with this ore body. We use these things to project what's happening in areas that we can't see at the surface so that we can predict in the future what this is going to look like. All of this information gets converted into a 3D geological model of the deposit. This is like a digital twin that we can use to understand not just what we see at the surface, but what's going on at depth. This helps us understand what the life of the mine may be, helps us understand what the risks are for people that will be mining in there, and a number of other different factors that we think about. We also care about all of the elements that are in there. This is an example of lithium. So we estimate what the lithium content is of the rocks. We put this into a block model. It's a very complex thing, but our mining engineers use this so that they can design and schedule what the actual mining will be like decades in advance. This is kind of an example of what this looks like when we look at it in profile. We can see here how our drill holes go through there, and the lithium is kind of extrapolated away from the drill holes to help us understand where it's going. And as we pull back, this is what the site would look like today. There is a big pit there. A lot of people don't know that. It's kind of hard to see depending on where you're at. You can walk around on the trails and the roads and not necessarily know it's all there. So what have we been up to? Current events, ongoing activities. This would be, we've had people out in the field doing mapping, looking at our pegmatites, trying to understand more information about them. The old-timers were pretty good about what they had, but they didn't document everything. And we have the ability now to look at a lot more sophisticated aspects of the deposit. So we take what we get from our mapping, we look at what we have in our drilling. If you wonder what the spodumene looks like, it's these kind of pale green crystals in our drill core there. We do mineralogy and metallurgy studies to try to understand, okay, well, how are we going to best and most efficiently get that out of the rock? We don't want all the other stuff around it, we really just want that. So we have to do all this work to figure that out. Other things we're doing, topographic surveys, aerial photos. We're doing sampling for geochemistry right now so that we understand the actual chemistry of all of the rocks, not just the stuff we're extracting. Probably the biggest impact thing that you'll see, or you may see around site, are drilling activities. We have these big kind of drill rigs that are currently sitting on Albemarle's property. We're going to have them moving around into different places. What is the point of these machines being around? So the first is we're characterizing the waste rock and tailings storage areas from the previous mining operation. We didn't have that. When they stopped the mining operation, they just kind of left. So we're trying to understand what the chemistry of those things are, what the stability of them is, the hydrology associated with them, just so that we can plan for how best to deal with all of those things going forward. We're drilling water wells. This is really in response to community questions about what's happening with the water. The pit is full of water, so we want to understand what's going to happen in terms of water balance with surface, groundwater movement. In order to do that, we put these holes in there so that we can measure and monitor what's going on with the water. Community considerations, the things that we always think about when we're doing this work is impacts to the community. You will see in some cases local closures of things like trails or in some cases easements for safety purposes. This is so that we don't have people walking up on a drill rig when they're running around riding their bikes, that sort of thing. But we do everything we can to minimize those impacts to the community, and it's generally just around the Kings Mountain mine area that we're talking about this stuff. We also have extensive efforts going on to survey anything else we may impact, utilities, property boundaries. We maintain aggressive erosion controls, monitor sound levels, and a whole variety of other things as a part of our drilling. So our hope is that you don't even notice this stuff is really going on. And in the future, if you are out there, if you actually see one of these machines operating, my advice would be don't just run up to it. Those guys are working hard to make sure that everybody's safe, and we don't want people just running around these machines. Speaking of community, I'm going to go ahead and pass it over to Trevor, who's going to talk a little bit more about the environment permitting.
Great. Hey, everyone. You might remember me from the last town hall. My name is Trevor Chessel, and I'm the Manager of Environment and Permitting. And I'll be leading a lot of the environmental assessments and, of course, the permitting processes for this potential mine development project. In our last town hall, I introduced our overall environmental baseline work that's needed to advance and support our various environmental impact assessments. And we've been advancing them, like Alex said, over the summer and spring since our last meeting. But we have quite a bit of work to do for the rest of the calendar year to button up the survey information that we need. My focus tonight will be on the threatened and endangered species surveys, which have been fully completed for the federally listed species. And if you introduced these scopes back in March when we met, and if you recall, there were two specific species that are on the federal list and have the potential to be in this general area of North Carolina. And those two species were the dwarf-flowered heartleaf, it's a plant, and the northern long-eared bat. The first that I'll discuss is the dwarf-flowered heartleaf. So since we last met in the town hall, we contracted a consulting company called SWCA. SWCA are a specialist firm that are experts in biology and assessment of threatened and endangered species. And they started their work by conducting and coordinating conversations with the U.S. Fish and Wildlife Services, the North Carolina Natural Heritage Program, and the University of North Carolina. And this coordination was to basically gather as much information on these species as they could, both from historical records, other surveys, and they even went out and looked at a reference population of these species in a different area of North Carolina. This information was used to develop a survey methodology to determine whether the species were present or absent on the site. So that's a key thing for us. We really want to know that early in the project development process. The survey methodology was approved by the Fish and Wildlife Services and included a series of transects, or basically cross sections that we walk across the property to see if we can see any on the site. The survey was completed across 100 acres during the dwarf-flowered heartleaf's flowering season. One of the important things to properly identify threatened endangered species is to go during their flowering season, because sometimes they're relative species that are non-threatened look exactly the same. So you need that flower color and general characteristics to really identify which species we have on the site. So we completed the survey in May this year, and we did find that we did not see any dwarf-flowered heartleaf on the site. We did see their sister variant, which is non-threatened, but the threatened variant of this species was not on the property. The next species I'll talk about is the northern long-eared bat. And although the Kings Mountain area and our project is on the very, very edge of where their habitat is included in the state, we wanted to, again, complete that survey to just get a high level of confidence on their presence or absence across the properties. In this case, SWCA followed a off-the-shelf guideline from the Forest Service, and that guideline required us to go out and install a number of acoustic monitoring instrumentation packages across the properties. And these acoustic monitoring instruments, they're capable of recording bat signals and differentiating between different bat species on the property. So we deployed 15 different sites and recorded over 7 nights each. That information was then analyzed to identify, again, which species are on the site. And we found, again, that the federally threatened species of northern long-eared bat was not on our property. So regarding these two federally listed species, we can conclude with high level of confidence that our project is not going to have any impacts. So that's great news. From a biodiversity perspective, we don't want to have our project impact or make a condition worse than it already is for any threatened or listed species. So it's great news from that perspective. If any of you are interested in reading more about it, we will be posting these technical reports to our website, as well as the other technical reports that we'll have over the next 3 to 6 months. So feel free to download those and read through and let us know if you have any questions. In addition to the threatened and endangered species assessments, the team's been busy completing other environmental and biological baseline work. These include stream flow measurements on Kings Creek. So we need to get a really comprehensive baseline on how flows differ from season to season in Kings Creek and other water bodies on the property, so that we can use that to get an accurate baseline. We installed a climate station, which is equipped with instrumentation that will provide key long-term monitoring for air quality and noise levels. We completed cultural resources surveys, at least 2 or 3 phases that we need to do, just to identify any significant historical sites, so like old buildings or foundations or access roads, those kind of things, as well as any potential indigenous artifacts on the property. This scope also included a cultural monitoring program, so when we're doing clearing work and drilling across the property, we've got archaeologists there on the site inspecting the areas before we do any clearing or disturbance activities. We've started a comprehensive water quality monitoring program. Every quarter we'll be sampling really comprehensive water quality analytes for existing water bodies across the property, existing groundwater wells, and any new wells that Matt and the geology team will be drilling. We've also completed some aquifer testing on the property. Basically what's involved with that is we drop pumps down some of the existing wells and pump it as fast as we can for 3 days, turn the pump off and let it recover. And that drawdown and recovery gives us really great information to see how groundwater flows across the property. And it's key information for us to import into our groundwater models and ultimately our environmental impact assessments. So I just wanted to reflect on a slide I shared last time we met, just on the overall work that we have in front of us. This visual shows all of the baseline environmental collection that we're doing on the left-hand side of the graphic. In the middle are all the alternatives analysis that we're also completing. And finally, the environmental impact assessments. So a lot of this baseline environmental work is going to be buttoning up towards the end of this year, but we do have some things that they'll push into 2023. While we've been collecting that baseline information, we've also been busy looking at alternatives analysis. So looking at different methodologies, how we can develop the pit, how we can deal with some of the byproduct and waste materials that are generated from the mine site operation. We also look at different options of handling water across the property and how we can maximize recycling, along with amongst a long list of other alternatives that we're looking at. So once we have the baseline information and we have all those alternatives assessed, we'll then use that information to look at each individual option and see what the potential environmental impacts will be. So as we work towards this, we do plan to share a lot of that information with you, mainly in the new year, starting in the spring. So in our town halls there, we plan to share some of the top 6 options for you and their associated environmental impacts and socioeconomic benefits. And we will ultimately need to align on a preferred alternative. So we want to make sure that our preferred alternative for development aligns with yours as well. So with that, I'll pass it on to Kirsten.
Thank you, Trevor. Can everyone hear me? Yeah? Okay, great. Hi, my name's Kirsten Martin. I'm the Community Affairs Manager at Albemarle. A lot of you may know, but I am a Kings Mountain native and resident, so I'm really excited for the opportunity to work on this project and to work alongside all of you throughout this. Okay. It's been mentioned already, but transparency is really important throughout this process. So as a part of that, we're working very hard to open a downtown information center in Kings Mountain. The office will be located in the old Griffin drugstore, right beside 133 West, as I'm sure many of you know, and it'll be open daily to the public and staffed by our Albemarle team. So the space is meant to serve as a community hub for the project, where you'll have access really to the latest information, all of the project updates, and you'll have an opportunity to talk with our staff while they're there on site. We want to make sure that we're encouraging you all to take advantage of this space. We're looking forward to having it open at the beginning of the new year. As you can see in the renderings here, the space will have a large open lobby for educational materials, community videos, and project updates. We're also working on a large conference space in the back of the building. That conference space will be open for the community to book for free of charge for any community meetings that are happening around town. Like I said, at this time, the Information Center is slated to open at the beginning of the new year, and we're really excited to welcome you all to our new home downtown. To help us to continue to engage with the community and to invite you all into this process, we plan to begin public tours of the mine in 2023. So starting next year, community members and local associations will be able to sign up for or register for these upcoming tours on our website. These tours are currently in development, and we'll begin some trial tours with small groups later this year. While we invite everyone to come and learn about the project, the tours themselves will be prioritized for community members here, so residents of Kings Mountain and Cleveland County first, and then open obviously to the surrounding counties and to the state as well. At the same time, we're also working on some educational tours for our students of all ages throughout the county, and are also exploring ways to include our Kings Mountain site in some of the STEM curriculum and career exploration. These tours will be educational and focused on the project, but we really want your feedback on what you want these topics to look like. So there are comment cards at the entrance where you came in today. If you want to take a minute as you're leaving today and give us a little bit of feedback on what you think would be the most interesting and the most important topics on these tours, we'd be really, really thankful for that. We're really looking forward to your feedback, like I said, on these tours, and we're really excited to, again, to open our doors to the community. And finally, a quick update on the Gateway Trail development. So as you all know, the existing trail was created on an 85-acre easement on Albemarle property, which includes the majority of the trail as it exists today. We've worked over the last year with Shirley Brutko, with the city and county officials, and also the Gateway Trail Board to determine a number of new potential routes for the trail that would ultimately give us an opportunity to build additional trailheads and public parks along the way. So as we announced in March, we're currently in the middle of a planned feasibility study for the proposed routes with the National Park Service. Once that study is completed in the coming months, we're excited to bring those plans for the new trail to the community for your feedback as well. This is really an exciting opportunity for us to build upon the work that has gone into the trail that we have today, and we're all really working collaboratively to find the right alternative that will benefit the community in new ways. And with that, I'm going to hand it back to Fernando.
Thank you, team. Thank you, everybody, for the update. Right now, we have a little recap. We looked into the geology, give you a little better understanding that we have some historical data, but it's not enough for us to understand truly in depth how the deposit is at, we have it now. So we're doing more drilling, we're doing more studies on the geology, looking at the different geochemistry, looking at the geotechnical, the stability of what used to be the open pit mine. So on the environment, we have a lot of work done. So we continue doing more work. So we really need to truly understand the environment and making sure that we're gonna be developing a mine that complies with all the standards. And we have something that will give us the information that we need to make sure that we respect and operate with the environment that we have around the mine. So with that said, now we're going to go into a Q&A. Any questions? Here's the microphone. Somebody who wants to ask a question to the team can come up so we can hear the questions. And like I said, the team is here to answer. If we don't have the answer, then we will get the answer for you as quick as possible. So please join us and let's start the discussions, questions, concerns that you might have. Open for everybody now.
So we had an update really recently. It's probably going to be the end of October, but that will be ongoing, just dependent on what we find along the way.
Okay, thank you.
Yep.
So yes, we're doing a pretty extensive hydrogeological assessment. So as Matt and I both talked about earlier, what that involves is drilling wells, not only in the immediacy of the pit, the mine pit, but also in other areas. And the reason for that is you need kind of regional information on what groundwater levels are at. If we only drilled wells around the pit, it would be kind of like putting blinders on in terms of when we're trying to understand what the environmental impacts are. So we have been, and we do have plans to install wells on our properties south of the highway as well as them north. And the reason for that is we're trying to push those wells to the very, very perimeter of our land holdings so that we get that regional information, right? And we start collecting data, not only close to where we're going to be mining, but also areas outside of that as well, right? So one of the things that we start, and I'm going to get into some of the details here, but one of the things we do is do those aquifer tests. So you asked if we're testing aquifers. The answer is yes. It's not necessarily for a water supply or an impact assessment or anything like that. What we do is it's a pump test or an aquifer test that I explained earlier. We put a pump in a well, we pump it as quick as we can, shut the pump off and measure as much data around all of the wells, not just that one well, to see what happens with the water, right? And that gives us information on when we build this mine pit and water naturally wants to drain to the pit, the deeper pit, that'll give us information on how fast it will go and how wide of an area of influence it would do. So that's a significant amount of work that we've got in front of us. We have to finish the drilling program first and then do I think we have 5 more hydraulic pump tests that we have planned. That'll give us that full package of information so that we can start modeling the regional and isolated local impacts. We don't expect many groundwater impacts to occur in that particular area. There's a particular piece of geology, which we'll talk about a little later, I would say next spring when we can have the full data set for you, but there's particular geology north of Highway 85 that is kind of restricting how much groundwater flow would flow north to our site. You asked about development. Currently, we don't have any major plans to develop our furthest south property. We kind of refer to that as a Wellman, but that's the property close to Lake Montagna. But we may look at if you recall, sorry, we don't have a map, but there's a old historic tailings storage facility just south of the highway, close to, that's been there since the 1960s or 70s. We may look at some opportunities there just to basically build a small reservoir for stormwater. But that's as far as our process today, those are the only things that we're really thinking about. With our first stage strategy of this development, we're really trying to put everything on the north side of 85, but we still have work to do to really assess what those options look like.
I think that you touched on a number of topics, and I think, Henry, you're in the audience, so you're going to come and talk about processing, so come on up. And I think before Henry gets there around the processing, I think it's worth pointing out that this site has sat idle for 40 years. And in that time, we've seen the pit lake fill with water, we've seen vegetation grow back, and we've seen fauna come and live amongst that. And there's fish in that lake, there are turtles there's all sorts of wildlife. Yeah, and I think have we got the clicker? Can we go to the slide that has the overview? So yes, I mean that pit there has gradually filled up with water, and all of that is rainwater essentially, and the water quality on that is actually reasonably good. And we have the testing, and we can provide that testing on what that water actually has. And I think if Kirsten's clicked through, I mean I think that's a great photo that sort of shows, hey, in the mid-70s, that's what that whole site looked like. And I think Trevor sort of spoke about. I'm going to come down here as well. Trevor sort of spoke about this area here, which was previously used, is probably the area that we're going to sort of consider for some stormwater stuff. So that's really the limit of our operations. And beyond that, so the 400 acres that sort of sits out here, we have no plans for that. So just to come back to that. But I'm going to let Henry talk about the process side and how we actually recover the lithium from the rock. So Henry is our group metallurgist, and it's his job to take the what we deliver to him from the mine and turn that into a concentrate.
So my name is Henry Walke. I metallurgist by trade. That's what I've been trained and all of that. The process you described there is chemicals. Well, Yes and no. When we receive the ore that comes from the mine, about 60% of that ore is going to end up on a mechanical process, if you want to call it something. It is based on light rock and heavy rock. You separate one from the other. So that piece never really sees any chemicals. So that you have a concentrate and a waste stream at like a gravel size. That hasn't seen chemicals. Then you take the other 40% and break it down even smaller. Talk about like face powder, something like that, maybe a little coarser than that, on that size. And then you add two main things. You add a frother, which is what makes bubbles. That is like your dish detergent. That is basically what it's doing. It is making the water change so that it's thicker water, so that the material attaches to that bubble. The material, the chemical used to make it attach to that bubble is called a collector. The collectors attach to the surface of the mineral, and then they have like call it like a tail, and that tail goes into the bubble, and that bubble carries it out. That collector is designed to stay on that surface of that mineral. So when you talk about, is it going to remain? When we recover and create a concentrate, it is carrying that chemical with itself. Now, the next step of the process after we produce a concentrate is to deliver that to a conversion plant, where the first step is actually calcining, burning it off. So the vast majority of the collector and frother, which are used to change the water properties, remains with the solids. It doesn't stay. There is a small amount that, yes, is going to stay in the water, but it degrades over time. It's not meant, it doesn't build up, it doesn't contaminate long term. I grew up in a mining town. I grew up in the mountains of Peru with copper mining throughout all my life. And I've seen the industry change, I've seen the industry evolve, and all of those things happen, meaning the concentrate carries the chemicals. We're not using anything that hasn't been used before. You ask about information. There is only 6 or 7 lithium mines in the world that use this process. This combination of two, the mechanical and the chemical combination of these two. At some point, if you want, we'll try to put some reference in the website so that you can go and take a look and understand all these steps. I simplify it so that we can have this conversation. But in principle, a vast majority won't see chemicals. The portion that sees chemicals, for the most part, will carry those with the solids that go to the next step of the process. They don't stay here.
And what is the type of chemical that's used?
One is a fatty acid, and it's a fatty acid. It's it's a tail oil. It comes from trees. That's basically what it is. It's not some long, complex name. Mineral processing, I don't like chemistry because it has those long names, and this one is easy. It's a fatty acid. It's just like a kind of a grease, because one of the challenges that we have is when we mix it with water so that it attaches to the surface, you have to break it down into very small sizes, and you have to, for lack of better words, use a super blender that is going to not dissolve it, but just emulsify it so that it attaches to the particles. So that's it's part of the chemicals that are for that process.
Yeah, so that just to sort of reiterate, make it clear, that fatty acid that's used comes from a tree. What type is it? A plant tree?
It's not tall oil.
A tall oil tree. So that's what's used in the process to recover the lithium from the rock that goes into the plant. So there aren't things like arsenic that are used. There aren't things like cyanide. There's none of that that's used in the extraction process for spodumene.
So we're not dissolving the spodumene to recover it. It's more of a physical process where we're changing the properties of the surface rather than dissolving it. When you get into dissolving, that's when you start getting into some of the more acids, aggressive acids, and things like that. That's not what we're doing. As I say, it's use mechanical separation for how heavy or how light it is. Use magnetic separation to pick up if you have any magnetic particles on it, and use flotation, which is, I think I use the same example. When you do laundry in your house, you add soap, right? And then it goes into your washing machine and it tumbles the water, and there's the suds. Well, we are doing basically the same. The laundry detergent that you're using, it's a combination of a surfactant that changes the property of the water and a frother that makes it bubbles. And to those bubbles, the dirt in your clothes attaches. And when you rinse the water out of the washing machine and the dirt go with it, it is basically doing exactly the same that we're doing. It's not much different than that. It's the same principle, it's the same information, it's the same technology. It's not anything crazy. Yeah.
That's one of the best analogies for process metallurgy that I've heard in a long time. I think your question is a really important one, so I just want to add one thing to it. You can go there and look at, this isn't new. The previous miners, they did effectively the same thing we're going to do. Those tailings basins, it's not like they did a bunch of work to reclaim them. They just stopped and they walked away. They're still there. You can go put your hands in them and see what that material was. From a geology perspective, we recover the spodumene. The other stuff in that rock is quartz, mica, and feldspar. The times when you see tailings and it's a scary thing, and I agree with you, it can be a very scary thing that needs to be managed and engineered in the mining industry. This isn't quite that. It's not sulfide rocks that have been saturated in acid. It looks like beach sand. It looks like a bunker at a golf course out there, and there's big trees growing in it, and it's probably the best case that you're going to get in terms of having to manage material that comes out of the back of a process plant. So the mineralogy, we understand that really well. Some of the drilling we're doing right now is to understand that even more. We know what we can see at the surface. We want to know what's down at the bottom of that. So we're doing a lot of work to try to characterize all those things so that we can come back to all of you guys and say, this is what the reality of that is.
Yeah, so we'll set up, part of the reason we push those wells again at the periphery of our property is to get point of compliance wells. So we'll start monitoring them right away as soon as we get them drilled this year, get that baseline, and those will basically be wells that represent our water quality compliance areas for all operations into closure and reclamation and decades beyond closure. So getting those wells in, again, as far as we can out on the edges of our property is really key so that we can start that process. Yep. Well, what we do with all of our studies that we're looking at, and there was one item I had on that left-hand column in our environmental baseline collection. We are completing a really comprehensive geochemical characterization program, and Matt touched on it a little bit. And what we do, we characterize everything, any kind of waste product that's going to be developed by the mine, any kind of residue or anything, whether it's tailings, just regular overburden, which overburden is basically the rock that sits on top of the ore body. We basically mine it and just put it aside. Or any waste rock, larger rock samples that come out of the processing plant. We characterize those with a very extensive geochemical program. It includes requirements from EPA, requirements from the IRMA standard. If you guys recall, we talked about that IRMA standard. That's the global industry standard for responsible and sustainable mining. And we also use some of the best industry practices to characterize it. So we send all those tailings and rock samples off to labs in Canada, in the US, and all over to get that work started in the lab. That gives us that baseline information, again, to just look at what's called fate transport models and leaching assessments. So what they do is they look at that rock, and in the lab they simulate years and years and years, decades and decades and decades of precipitation falling on them, and it basically proves or disproves that any kind of chemicals or anything in the rock, and I'm not talking process chemicals, I'm talking natural elements that are in the rock now, that it proves or disproves that whether they'll stay in the rock long term or whether they'll potentially have the risk of leaching out off of the rock. So that's the geochemical program that we're doing. It takes a long time. We sent over 400 samples just to start some of the preliminary testing. We've got probably that much more to send. And some of those samples will start this year, and then we'll run for almost 2 years. So it's a very, very comprehensive program that we're doing to fully understand the risks of any kind of leaching off of that rock material. And the thing that we're worried about most in mining operations, since the processing that we have here isn't going to introduce any kind of dangerous or toxic chemicals, the thing that we're worried about is the natural, what's called oxidation of that rock. So it's minerals that are in that rock that once they're exposed to air and precipitation, it can start a natural chemical reaction. And that's really what we're trying to resolve with this geochemical testing program. Fortunately, lithium is significantly less risky than, say, copper commodity or copper mining or iron ore and coal. We still need to do the work, but the chemicals, the natural minerals that we see, in this rock are less risky than other commodities. So it's a good thing for the lithium industry, and that risk is not quite as apparent. So lots of work to do, and again, we will start sharing those detailed technical assessments with you in the spring, and start talking in detail about the potential risks and more importantly, our mitigation strategies to minimize those.
So when you're talking about the battery, so we're going to mine spodumene ore and generate a spodumene concentrate. Okay, the concentrate, it's basically an inert sand. Then it goes, I alluded to this when I talk about calcining, and then it gets dissolved and it goes into the lithium metal or other forms. Those are what go into the batteries. For when you have what you're talking about, the risk of fire and all of that happens once you've processed, once you're out of here. So is there a risk for us working or living in this area? No, that's not present based on what we're doing and what we're producing. When you have the risk of fire is on the final product, on the chemistry, because it's a chemical reaction that generates energy, right? That chemical reaction can, if it's not properly handled, can, in some cases, under specific chemistries, result on a fire. That's what you're referring to. So you probably have more of a chance on certain type of vehicles that are using a specific chemistry that is going to happen. That was with the bolts. I think it was one of the vehicles that was having some issues and they had to recall and wait. And it was on the fabrication of the modules of the batteries where they had issues. So for the rest, the people that lives in Kings Mountain, that is not a risk. It's not something that we are introducing. It's not something that is going to happen at our site because we're not making batteries. We're making the raw material to make the pre-finished product that will eventually go into a battery. There is a number of steps in between from what we're making to a car battery.
And it's worth pointing out, just to touch on, you and I might think of it just a battery and all batteries are the same, but the chemistry within the battery is different depending on the cathodes that are used. So that goes into an area that's way beyond my area of expertise, and it only it's very rare, number one, and it's isolated to a specific battery type. So not all batteries are the same. I think on when we expect to come into production, it's obviously subject to a number of variables, so I'll caveat that by saying that at the outset. But we hope to be in production, or at least ramping up our concentrator, late 2026, early 2027. In terms of, and I guess where are we now? We're in 2022. I guess that just shows the level of study that's ahead of us. But additionally too, there's the construction component that comes along with that. So, in the interim, we've got to build this thing. That's 500 to 1,000 jobs that would be involved in that, and then there's the actual operation once it's all built and constructed. In terms of the life, look, this has the potential to be a multi-decade operation. We are evaluating what that optimum configuration is going to be. It has the potential to be 20 plus years. Our first phase that we come back is probably going to be less than that, but obviously subject to further expansion. So there's a lot to work through, but they're kind of the rough parameters of what we're working to internally. You would have heard our leadership talk about the construction of a downstream refinery as well. This operation is what we consider as the primary feed into that sort of facility as well. So a lot of work to be done, a lot of engineering, a lot of environmental studies. Obviously, we want to sort of bring everybody along that journey, and we continue to sort of advance. I think you heard today that one of the things was that whole timeline would have been irrelevant had we sort of found any sort of endangered or threatened species, which we now can sort of sit here today and go, okay, we haven't got any evidence of that. That gives us confidence to move forward. So there's still a number of toll gates along the way. Has huge potential, but we want to make sure that we do it safely, sustainably, responsibly, and respond to sort of any of the concerns or questions that you have along the way.
So that's the closure and reclamation. So the first step is to obviously close the mine. So it would involve demolition of all the infrastructure and buildings on the property, and then closure is quite complicated. It can be and reclamation can be really anything, and we want to include a dialogue with the community on what our end land use is going to be. That's kind of the first step of doing closure and reclamation studies. And what the end land use is, it's a decision between Albemarle and the community in terms of how you want that site to look at the end, right? So it can vary. The most common closure and land use is, bring it back, reforest it, revegetate it, and bring it back for recreational use, much like you see today with the Gateway Trail. It can, if the community wants it, it could be repurposed for maybe commercial development or other industries development. So there's a really wide range of options. And early in the new year, we're going to be reaching out and trying to harness some more of your input in terms of what that end land use should look like. If we choose, say, a wildlife or reforesting and revegetation type recreational land use, that would involve doing a significant amount of work like capping all of the waste materials with topsoils. So one of the things that we're going to need to do is, if we clear any new areas for the development, we'll have to actually excavate and salvage the topsoil. So there's mainly 3 or 4 different soil horizons that we will salvage. And one of them is the top zone is like a seed zone. And it's basically all the leaf litter that's there naturally. You scoop that up, you put it in an isolated pile on the site, and you leave it there, and you wait until the whole mining operation is done. You recontour any of the waste dumps or any of the facilities, and you actually pick that up at the end of the mine life, put that seed zone and key topsoils back and reclaim it so that vegetation can actually grow. So it's significant. I spent almost a decade in my career working solely on mine closure and reclamation projects in both Canada and the U.S. in quite a few states and provinces, I'll add. So it's a really complicated process, but there's very good practice that we can do, and we certainly, the first step is to get community input. What do we want that site to look like at the end, and then we go from there in terms of the engineering design and all of those soil assessments and biology assessments as well. So another example is the pit. Our current thinking right now is that we would let it fill with water, simply what we've done over the last 30 or 40 years, and you can have that pit resource there. So there's a lot of different opportunities for hiking, for biking, and recreational use that we can consider for this property. So more to come on that in the new year. And like I said, we really want your input on that as much as we can get.
Plus or minus 1,000, I think, between both the existing site and then on the other property on the other side of the interstate. So 161, John, we don't have any further plans on 161. No further plans on 161.
Yeah, I mean, everything right now on the land, we were focused on the areas adjacent to the mine, and the production area is still to be determined, right? So our land acquisition is kind of fluid right now, to answer your question.
But yeah, I think we've been in touch with everybody more or less that we have an interest in.
So one of the other, again, baseline assessments that we do is a traffic study. So that's one thing we're going to be starting towards the end of this year. And you've seen those little strips that go across the highway, the little rubber things. Every time you drive over that, it calculates your, how many vehicles driven on that particular road. So that's what we're going to be doing. You'll see those around our site at key intersections around Kings Mountain. We'll leave them there for a certain time period and test a few different seasons, right? So we want to make sure that we get the busy season and the slower seasons as well, so we fully understand the differences in baseline traffic patterns that we have. Once we have the full mine design ready and Henry has his design of his processing plant figured out, we'll know how many shipments of materials we need. We'll know how many shipments of produced product we'll ship off of the site. And we calculate basically right down to the truck on a daily basis how many people are going to be driving in and out of that facility. And not only shipments, also just our employees coming to and from the site. So we use existing traffic patterns, our predicted traffic from the project itself, and that will identify any key risk areas. So if there's a particular intersection in Kings Mountain, one we know right by the Holiday Inn Drive, that's a pretty dangerous spot with the other operators, the quarry operator here next to us there operating. So that's an intersection that we'll have to identify if it's a risk, and we know right now it's a risk, and we'll have to work with the city of Kings Mountain and look at different options there, whether it's something as simple as new traffic lights or something as large as a roundabout or new kind of a new way to turn when you come in and out of our property. So it's a pretty big study, and again, lots of work to do on that as well.
We're also fortunate in that we have the rail spur that comes into our property, and we envisage that a good portion of our materials could potentially use that rail spur to sort of keep vehicles off the road as well. So.
And you asked about noise and vibration. So again, I keep going back to these environmental baselines, but we have already installed 2 different periods of noise monitoring instrumentation on the site. So these are little remote noise dosimeters that basically, it reads the decibels of noise that are currently happening across the property. So we've got one on that Met station that I mentioned. So that'll be a permanent noise monitor. It's recording now, and it will continue recording all through operation and even after we're done and gone. But these remote dosimeters that we've been deploying on the site, we've been locating them, close to the edge of our property, specifically for the purpose of making sure that we know what noise levels you guys are experiencing now without us operating. And that's not zero. We've got a rock quarry operating next to us, and you've also got that busy highway in the area. I'm sure you guys can attest is a busy and dusty and noisy spot. So we're getting that information to solidify our baseline information so that when we start doing these assessments on potential noise that might come from our trucks or other areas such as blasting, those kind of things, we'll have that information. And pretty much everywhere in the design, we're going to be looking at options to mitigate noise and dust and vibration to the community. So Bill, the gentleman sitting right in front of you, he's already looking at the best technologies in terms of blasting techniques. So we want to just use the technology that we can to minimize that noise, minimize the vibration, and minimize the dust that will happen.
So let's go to the map. So this here, when you say 161, you're talking about this parcel here, or you're talking about this parcel here? So this is the 85?
To be honest, I think the one south is what I was.
This one here? Yeah, so this one here we don't have any plans for, that's the 400 acres or so.
That's the one near Lake, I'm sorry.
Yeah, that's Lake Montonia down here. Yep.
Okay.
This one here, I guess we are still evaluating that as a potential processing site. Henry, who you heard from earlier, is doing some of those studies. So essentially we would extract the material from this side of the highway, probably go over the bridge here via a conveyor potentially, and we're looking at options where we can sort of place that on that side. And the finished product there will be a concentrate, a rock concentrate, and we would either put that on the rail line or potentially get other question you asked in terms of who our customers are, look, our customers are, if you see an electric vehicle, good chance it's got, lithium that comes from, one of our operations. So, our customers, are managed by a commercial team, and essentially our job is to sort of get it out of the ground as safely and responsibly as possible, and then they sort of take care of the downstream.
And to answer the question about what 61 asked earlier, basically every property that we have an interest in acquiring as part of the project, correct, we have knocked on that door, we have made that relationship with individuals. So if you haven't heard from us on if you have lands in that area, that means at this current time, it's not part of our future expansion. Just on the 161 side. Right now, when we get north of the interstate, our focus is really along the perimeter of our existing footprint we've had for years. Anything after that is more of, right now, we're still finalizing plans on what exactly going to be the layout of the operations. So as we evolve, there may be additional lands we purchase, but that's our focus right now.
Yeah, and a lot of our land acquisitions are based on, I think your question, it's about being that responsible citizen. Some of those properties, are close to our operations and we sort of hear the noises, which is why we sort of want to establish that, buffer for our operating footprint. So that's a big part of why we've been acquiring that. The rock is in the ground where it's in the rock. Where it's in the ground, it's very hard to sort of pick it up and move it somewhere else. And essentially everything that we've sort of been picking up is just about establishing, that right buffer more than anything. Yeah, so a couple of things. So Cardio Hill is actually the remnants from the previous one. So people wouldn't be able to enjoy Cardio Hill if it wasn't for, the operation that was, many years ago. Look, dust management is a really important part of a modern mine. If you have a dusty mine, you don't have a good mine. And, I think Fernando can sort of talk to that in a little bit more detail, but, we have limits. We need to manage air quality, we need to manage all that, which is why we're doing all the background data collection today. But when you look at the existing operation that's there today right next door to us, it's just going to be a very similar type of operation. We have committed to the Gateway Trail that we will retain the Cardio Hill pathway, and that's sort of been our commitment from the beginning, and that area is free to sort of be used throughout that process. In fact, one of the things that we have sort of proposed is potentially having more of a lookout where people can walk up Cardio Hill and have a look at our operation as well. So they're the things that Kirsten is leading in conjunction with the Gateway Trail and the city and the county around that.
Yeah, as part of the design that we're looking at dust suppression where we might generate some dust. So this is part of the process that we're designing to mitigate that. So, our purpose is to eliminate or mitigate, right? So that's just part of the mine design when we do the blasting, when we do the roads maintenance, so when we stockpile ore, sometimes it's dusty, so we're looking at different processes and machinery that will collect that dust and include it where it needs to be at. So nothing there. So this is part of the design. So we're looking at that. Today, mining basically has a lot of innovations in terms of dust suppression. So we will be able to ensure that we have taken care of that as well.
Most mines have one, if not more, generally more water carts that sort of continuously, do their rounds to ensure that dust isn't generated from the operation.
And on the safety side, we can't generate dust. The Mine Safety and Health Administration, MSHA, we can't generate dust from the truck, so we will have water trucks. Roads have to be damp, compacted. We'll have speed limits. Bill will design the road so certain speed limits, and that'll reduce that dust as well. Yeah, so the MSHA is federal, and North Carolina does have a state inspector as well. They're more for just education, guidance, helping us do things that way, where MSHA is more of they help us as well, but they're more of an enforcement agency. Just like I said, if they come to the site, they'll actually come to our site twice a year, probably 2 to 3 weeks at a time. And if they see a truck generating dust, here's you
Ticket.
The ticket, yep.
Oh, I know.
Yeah.
Yeah, and that'll be probably one of the first permits we submit. In order for us to start any kind of dewatering activities, we need a permit for it. And that's called a NIPDES permit. So it's called it's a long one. It's the National Pollutant Discharge Elimination System Permit, NIPDES. And what we need to do, we're already starting on some of the technical assessments to support that permit. The first we need is a flooding assessment. So if we intend to discharge that water to Kings Creek or any other creeks in the region, we have to ensure that we're discharging at a rate that's not going to cause any kind of new sediment or erosion in the creeks or stream that we're discharging to, and it's not going to create any kind of downstream flooding risk potential. So our kind of base case strategy for that is to discharge to Kings Creek, similar to what the adjacent mining operator is doing today. So the Martin Marietta pit has been discharging to Kings Creek for many, many years. And we did that in the past also when we were managing water during mining operations as well. So that's probably our base case, but we are looking at different alternatives. In addition to flow, we need to prove that from a chemical perspective, the water in that pit is suitable to discharge and it's not going to, contaminate the environment downstream. So that's basically where we're at now. We're doing thorough assessments now on that pit. The guys were literally out there today on a pontoon boat, and what we do is we sample a full analytical suite for water chemistry at different depths. So there's 3 or 4 different areas on the pit that we sit the barge. So if you see that barge out there when you're walking across Gateway Trail, that's exactly what they're doing. They sit the barge at 3 different locations in the pit, and they go down 10 feet, take a sample, go down 20 feet, take a sample, go down 30 feet, all the way to the bottom. So that we get a very comprehensive profile of what that water chemistry looks like in the pit. Once we have that information, once we finish our geochemical assessments on it and the lab testing, we'll basically be coming up with a strategy on how we need to dewater the pit. So one's flow, the other's chemistry. If the chemistry isn't suitable to discharge, for the most part, it meets the majority of the surface water discharge characteristics now in terms of metals and other components. But the thing that we need to sort out is at the very bottom. If you can imagine, that water's been sitting there for almost 40 years, right, and accumulating. So the bottom water is low in oxygen, and it's basically stagnant water. It's been sitting there for so long. So that's the thing that we're assessing now, just to make sure that we can discharge that. It doesn't deplete oxygen in Kings Creek or other areas that we send it. So lots of work to do there. And if there is any issues with that or concerns with that water, we'll need a water treatment plant. So we can't just discharge directly if the water quality isn't suitable. Probably that's our plan now. So we're hoping by the end of the year we've got those technical and technical assessments worked out. And again, if we feel that we need to design a water treatment plant, that's a little bit of extra work we need to do before we're going to be ready to submit our permit. I would say probably the best case scenario is we'll submit the NIPDES application by the end of this year, but it might give or take a few months. Usually NIPDES permits take about 12 to 14 months for the regulator to review, get into the technical discussions with us, post it for community comment, and then approve or disapprove. All right, so we won't start that for at least a year, maybe about a year and a half. And the timeline to get that pit basically dewatered and allow us to go in there and start some of the early mining work, it just depends on how much flow that we can send to the creek. So it's probably anywhere from 7 to 8 months at a high end, but at a low flow, it might take as long as 2 years. So we're working on that strategy. In that range, it generally aligns with the production target that we've got that Alex discussed. So it's not an absolute urgency for us to start tomorrow dewatering that pit. We've got at least a year of permitting to do for it and more technical assessments before we're ready to submit an application. Yep.
Thank you. Any more questions? All right, Alex, I think if we have some more questions, we have some water, coffee, tea there. Maybe we can continue here. We're going to stay here for a little bit and answer some questions somebody want to approach us on a one-by-one basis. So thank you for coming. We really appreciate your time. We will continue doing updates, doing these meetings. Like Kirsten mentioned, we're going to have the information center open I'll be there once a week, probably a couple times a week to answer all the questions that you might have. My team also probably is gonna be, we're gonna be rotating, making sure that we have people that are working directly with the project, answering the questions for you in that information center. So, I don't know, anybody else, Kirsten, no more questions? So thank you very much for coming and for the good questions. Thank you.